Allen, thanks for coming on the show.
Thanks for having me.
So I got to hear you first at PTC. I don't know if it's the first time, but most recently at PTC. And one of the things that it struck me as I've heard you talk is you've been vocal with some of the challenges, no disrespect intended, for legacy networks for a while now. But I wondered if you could elaborate on what are some of those challenges either that have evolved or are intensifying with legacy networks? What do you mean by that?
Yeah, no, it's a fair question. I mean, it's something I've certainly been passionate about for over a decade here in my career, and trying to solve problems to meet the scale and demand that's come along with healthcare in our world. What we
Hmm.
initially started building for. But the legacy networks, I mean, really the issue is, why were they built and who were they built by, right? What was the purpose? Most of these networks were built, from the late 80s, early 90s through the early 2000s. Any long haul network that's, say, more than a few hundred miles long, connecting city to city, was originally built, by an ILEC, and it was built for the purpose of replacing, old microwave networks for long distance phone calls. They put fiber in the ground, but nobody could have foreseen what we're dealing with today and what
Hmm.
the networks are going to need to support. So what happened was a lot of it got direct buried. Um, a lot of it was low fiber count, fiber types that we don't even use today anymore. And so what the characteristic that they all hold is that we're second fiddle in the right of way. So even the ILECs, when they built their originally legacy networks that we're still using today for long haul, they rode rail right of ways, they rode power right of ways, they rode gas pipeline right of ways, they rode public transportation right of ways, and all having their own dynamics and issues with those. So there weren't a whole lot of really good, clean long haul builds. Uh, and even those ones that were done, say clean, were not, again, done with multiple ducts, so you could go back and populate new fiber types as things change over time, or with just high count fiber of good quality fiber at the time. There's a few exceptions that are still in use today that were good, clean long haul builds, but some of those examples included a gas company who started a telco company. And so the telco built on the gas pipeline right away. That was really clean and easy. They'd go 20,000 feet, splice at the end of reels, did nice, clean long haul builds city to city. And that stuff's still in use today.
Mm.
So the problem with the legacy networks is, the right of way, who they were built by, who owns them now, what was the purpose of them initially. And so where we've headed today is we have this long haul need. The networks aren't there, and there's no one out there doing what the ILECs did originally, dealing with rail, power, gas, public transportation to go build new ones. So
Mm.
we're sort of limping along with these legacy networks and trying to modify them to fit the needs that we have now, especially with say AI, and the demand that this is causing, just in scale, say between rack to rack within data centers, how massive that gets. Well, that same problem expands if you want to move a geographic location and connect those two data centers. Now you need long haul at that scale. And when you're left with fiber that was put in the ground in, say, 1998, hasn't been maintained well, has a lot of loss issues on it, the new equipment that comes out, the theoretical scale we should be getting is actually not showing up in the real world when we put brand new equipment on this old fiber.
Right. So, one of the really cool things about your world and my world is that if somebody's not from this world, they have no idea what any of these acronyms are. And I love it. We get to be super exclusive. However, our audience wants to know. So, when you say ILEC, what's an
Yeah.
ILEC?
Incumbent local exchange carrier is what it stands for. But essentially, but before the Telecom Act of 1996, divestiture they call it, it was all sort of one big phone company, AT&T, Ma Bell, right? And this is what built all the original phone networks around the country. And then with the divestiture, then you allowed what are called CLECs, the competitive local exchange carriers, right? And then that was through a tariff system, allowed people to use those old networks. So largely, what's happened is most of that network has been replaced in the metro and regional fashion with new fiber that's been built since then. But the
Mm.
long haul still remains an issue city to city, and we're still reliant on, a handful of companies that are on a handful of right of ways around the country on some very old aging networks that will take a long time to rebuild.
Now, when you say long haul, and assuming not a telecom audience listening to this, I've heard things described as the metro area, a middle mile, a last mile, and a long haul. Is there a distance? Is it a certain amount of capacity? Is it a type of media type? When you say long haul, what does that mean, do you think?
Yeah. Yeah, it's kind of all the above. It's usually so metros, within say 60 kilometers, let's say. I mean, people use different benchmarks, but somewhere in below the amount of distance that you'd need to use regeneration in a signal, where you could just take a pair of fiber that's, so long, put an optic on it with enough power and light a certain amount of capacity. When we go to long haul systems, we're talking about things that are over a few hundred miles. So you're going to have more than say 2 or 3 amp sites in the middle.
Mm.
We'll call it 2 at the most, right? So if you can space them approximately 80 kilometers at most, 80 to 100 kilometers for amp sites and spacing, then anything over say 200 kilometers, I would consider a long haul. And those would be the things that you need. You're going to be going through multiple cities from one big city to another, and you need a continuous right of way to make a build happen, a new fiber build happen. And the legacy, like I'm saying, the legacy long haul networks built to replace old microwave networks for long distance phone calls, we're not up to the challenge of what we have today. But there's really nothing actively working to replace them now. It's sort of happening piecemeal. Metro. So Metro will say is up no regen under say 60, 80 kilometers. 60 is probably a good benchmark. You get over that, maybe you do one regen. I still would not necessarily call that long haul. I mean, that's more the middle mile segments, a couple 100 miles or 100 miles, let's say 100 kilometers, 100 miles. And you get to say 200 kilometers and more. Now you have, at least 2 regens in the middle with, say ROADMs or access points on either end. And now you're looking at the quality of the fiber really starts to matter. That's when your loss and tuning the system starts to matter a lot in terms of how much capacity you're going to get out of that equipment. So Sienna, who we use and manufacture almost exclusively, but at least for all of our long haul DWDM and subsea stuff, we're pretty much Sienna. They come out with a new generation of cards almost every year, and each generation is theoretically supposed to get more and more capacity, modulating on a carrier wave, a certain channel size, right? And that capacity just keeps going up and up, and it's amazing what they're able to do. But if we start talking about routes like Mox operates a route from Chicago to Seattle on a rail right of way that's 4,400 kilometers long, and we don't do any optical to optical conversion in that. And so end to end, even with the most brand new technology from the best of breed manufacturer, theoretically we should get 600 to 800 per carrier wave, but we're more in the 350 to 450 range at most, right? And that's due to the quality and age of the fiber, right? It's just you're going too far on old cable, and the systems are not able to tune as they theoretically should, right? So this is sort of the reason for needing to replace these long haul networks when you get over a certain distance. The capacity becomes in question. It becomes a bit of a science experiment as you go to light it. And the factors that really matter, not so much the benchmarks that the new equipment has made, but that characteristics of the fiber. And that can vary so much on legacy networks, long haul legacy networks. They're not maintained very well, or haven't been maintained because of consolidation in the industry. So there hasn't been a good contiguous maintenance for the last 25, 30 years on these cables. So, where duct systems got cracked and flooded, and the pairs that were in use got repaired, but maybe the rest of the pairs didn't. And then when you go to use those cables or those pairs in the cables later, you find out they're no good. And so then there becomes a lot of cutting and splicing the cable, and then you end up with individual events, loss events in that cable. All of those start to affect a system, especially with the longer you get on those systems.
In my mind, as a data center person, not a connectivity person, it's almost like a road. So or the interstate, if I drive from Atlanta to LA, I go through the states have certain amount of responsibility for maintaining their, even though it's federal infrastructure. And sometimes it's smooth and clean, and other times it's less so. It seems like there's always construction on it. But is that a fair comparison, like the routes? But it seems like what you're describing, though, is, yeah, maybe, but these are private. And so you don't have a unified necessarily way to address the infrastructure. So it'd be like if Interstate 10, Interstate 20, Interstate 40, et cetera, across the country are owned by different consortiums, and they may have different, one may every half mile or 5 miles have an interruption, and it may be poorly maintained. It may be well maintained. Some may have easy, good, modern off ramps or segments of it, and others not. Like, is that what you're describing? That it could be inconsistent?
Yeah, I mean, it's a fair analogy. It goes maybe just to torture it a little further. It does kind of actually go one step further in the fact that, look, the interstate systems were built in a massive expansion, right? That was fueled by federal government to say connect things for the purpose of the military initially, right? Like so
Right.
that was we had it was more of a I would call that kind of a moonshot type of operation. Like you're going to dump a bunch of money into it and you're going to do it contiguously with federal authority. Right. That's not happened with broadband, right?
Right.
That's so the right of ways are in conflict, we'll say. So
Mm.
the federal interstate system, yes, originally, let's say, permitted or eminent domained by the federal government, but the state DOTs administer those, right? So
Mm-hmm.
if you're going to go build on a Department of Transportation right away, you're going to deal with all those individual agencies. It's not like you just would go to Pete Buttigieg's office and get one permit that you could go across I-90 from Boston to Seattle.
Have you been to Mississippi? I'm not saying Mississippi gets it wrong. I'm teasing Mississippi. I'm sorry, but I'm just saying there's some states I've been to. I'm not sure they got that memo, but keep going.
Yeah, no. I mean, Wyoming is a good example of a state that did a statewide one dig policy. Of course, they did that with the ILEX, I think Quest and maybe AT&T at the time, if I'm not mistaken. But they said, look, we don't want our state to be ripped up or our freeways to be ripped up a bunch of times over as competition would expand. So why don't we give the right to say we're going to put in the duct system one time, everybody contributes and put it in once, each person, however much they invested, gets their own duct. And that was
Right.
more of what they call a one dig policy. They did statewide, right? So I mean,
Mm.
not a bad solution, right? But if you could, say duplicate that nationwide, that would be one thing. It might be, relative more to the analogy that you have,
Mm-hmm.
but that's the big difference is that we don't have that in broadband. So we're piggybacking on all of these other right of ways. And while DOT would seem like a good option, it has its own dynamics, as does gas, as does power, as does rail. But
Mm-hmm.
we're second fiddle to all of those things. Like, for example, transportation, especially if you do a project like a rural broadband expansion. I mean, hopefully you're encouraging economic development in the region, and that leads to population growth, and that leads to road expansions, and now you're relocating your cable. Okay, so
Right.
as a right of way, that can be problematic as you look back over 20 years and how many times did you relocate your cable, as opposed to say a gas pipeline doesn't tend to move. Neither does a rail network. Very
Right.
often they're not moving these things. So, but when you deal with rail or gas or power, again, you're second fiddle, and you come second to all of their safety concerns that relate to their industry
Mm.
and their primary product that they're moving, right? And they're making money on. And if it's rail, it's freight, right? Power, it's power, and gas, it's gas. So they're not going to care too much about your telco priorities, and that's the thing that's in conflict for those long haul right of ways. So the some type of federal unified right of way could theoretically solve, somewhat of the issue in terms of the regulatory stitching together a contiguous right of way. But the difference between the legacy networks and the networks we need today is the networks we need today are not just a recreation of what was built with the legacy networks. Each cloud provider, the largest consumers of bandwidth, are the big cloud providers. These guys are the ones consuming all of the fiber and all of the bandwidth and all of the colo,
Mm-hmm.
and each one of them has a different reference design with a different topology that has a different priority set that's running different workloads and batch loads against that infrastructure. We have our own within our world within Nant Health,
Mm-hmm.
and Nant works with a parent company, right? In terms of us doing genomic and proteomic sequencing for the purpose of personalized evidence-based medicine.
Mm-hmm.
The scale becomes enormous with that. And that's the exact same thing that these cloud providers are facing is just massive scale. And how do you sync databases that are so massive that live in different geographic locations? But you need to deliver the results of all of that compute and storage work and batch load computing to end users that exist all over the place. Right. So it's a much different topology, network topology that how we're moving bits now. And it becomes really, we almost need purpose-built networks for each individual massive use case, right?
Hmm.
Now, there's some main routes that probably could serve a mutual use like the legacy networks do today, but then you end up again in the situation of redundancy. So it's not like you just need to have one new long haul network built. You need to have multiple long haul networks built that are redundant from each other that meet the specific topology needs of the largest consumers.
I one of the things. So so many questions, guys. We're gonna go way off script, but probably not. But I'm gonna try to stay tight. But again, back to sort of the road. Forget the road proper for a second. Just the uses of the road. So let's presume, to your point, either it's Eisenhower's 1952 or it's, I don't know, future president, and we have similar initiative. We've got a bunch of GIs. We want to, that need jobs. We want good paying jobs. We want infrastructure that allows us to connect to the modern economy, meet national defense reasons, to economic incentive, manufacturing, all the things that this infrastructure would be the lifeblood of. And so we could deploy something. Well, today, on those roads, we have a wide variety, or rail for that matter. We have a wide variety of traffic. We have local traffic that never leaves the area, but they might ride a segment of that interstate. For example, I'm just outside of Atlanta, and my neighborhood is just off the main freeway from Atlanta up to Charlotte. And my kids drive that segment. They've never driven to Charlotte. They'll probably never drive. Well, at least they haven't yet. They've never driven to Florida, although that's one of the routes from Florida, Mobile, Alabama, all the way up to the Carolinas and through. But they ride that little segment. So they treat this long haul, but they just use it for a segment. And there's traffic that crisscrosses it, et cetera. And so that infrastructure is able to handle a wide variety of traffic. It sounds what you're describing is our traffic. What would it be like if you had, for example, when I think about modern traffic, machine to machine communication, not just I as a human being am leveraging more of my IoT stuff. Like I'm generating things, I'm receiving something in response, but literally my refrigerator is talking to my grocery store because I got a standing order of list. And so it does some inventory. You know what I mean? Like the devices are talking because they've got some prompt that I've given them in the past, and I could tell it to stop, but they're operating autonomously at some direction that I've given them. And so this is now, even within my home network, a lot of the traffic. It's not me clicking on the YouTubes and watching something. It's my systems monitoring each other, alerting each other, taking action on my behalf, either intranet or internet. And so it might even get to a point in my home network, my local network, where I want to segment. I certainly segment my guest from myself. But is that what you're talking about? We might want to build infrastructure that says, look, some of this traffic, if you had 85, 90% of that traffic running through Atlanta, which is what it feels like, is just long haul autonomous trucks just running. And so it's difficult to get on, use it for 10 miles and get off. Whether it's, the second level above it, like they did in Austin or whatever, so, subterranean or, drone, to have different lanes purpose built for those things so it can relieve the legacy infrastructure, which is just fine for me going to my Styx concert in just a few hours, but it's not great, it's just fine for school traffic or whatever. But for commerce, that the interruptions are a problem, both for the people that are getting on and off, and that commerce itself that's just trying to be efficient and it's not going to get off for another 4 hours. Am I understanding that, or am I just confusing the whole thing?
No, I think you're hitting on a really important point of what the legacy networks are and how it's really created the way data flows today because of the way the old legacy networks are built. So here's the example: is you're absolutely right. The legacy networks don't have a lot of good, efficient on and off ramps, and the reason is when you go from, let's say, a population center like Minneapolis to Seattle, there's a lot of space in between there, and there's not a lot of people. So the economics get difficult to sort of add that on and off ramp to the fiber network. It gets
Right.
costly. And then again, it's owned by a handful of legacy carriers who aren't really interested in doing that, right?
Mm-hmm.
Beyond what their obligations are to regulation. So yes, that is a quote unquote solution. Well, let's go back to how it exists today. So on these legacy networks, without all those on and off ramps, and you are requesting some data, or a machine is requesting some data in, say, North Dakota,
Mm-hmm.
it doesn't get to hop right on the long haul network and get right to the city, right to where the peering traffic is coming from.
Mm-hmm.
It's a pretty roundabout way that it accesses where the data actually is, and that's a symptom of those old legacy networks not having an on and off ramp where they need to be throughout the country, so you could actually funnel data into the networks in a more efficient manner. So, like a good example is if we did have a lot of on and off ramps throughout the country on, say, a theoretical network that we dream about building, right?
Mm-hmm.
You could make this thing multi-purpose, but let's just use like satellite internet as an example. This is why satellite is preferred in the sticks of Montana or the sticks of North Dakota over your local DSL provider, um, because what they've managed to do is create a triangulation from the customer out in the sticks to a satellite and down to a peering location or a backhaul location,
Mm-hmm.
right? That's what they're solving a middle mile problem or a
Mm-hmm.
last mile problem, but really a middle mile problem.
Mm-hmm.
So you might serve the folks in North Dakota by having a downlink tied into a fiber long haul network in Minnesota, in Minneapolis, but you're going to serve the guy in eastern Montana or western North Dakota with that triangulation of satellite, because there is no direct on and off ramp out in the middle of North Dakota, right? So you're hitting on a very important point that without those on and off ramps, we create weird patterns of data that aren't very efficient. And as
Mm-hmm.
our scale starts to grow, the efficiency could probably handle some of that. So if we do this again, this thought exercise of we have this dream contiguous right away, the feds have granted it to us to go build this open access duct system to pull a bunch of fiber through, and anywhere anybody wants to add on and off ramps to it, they can. I mean, you think about the things you can do. Yes, solve the long haul problem I've been describing initially, but rural broadband expansion, that becomes a much more different and more efficient conversation at that point. You're not just doing sort of a tax transfer to the legacy networks to shore up their balance sheets as opposed to build fiber to everybody's home like they're supposed to, right?
Right.
This is you're talking about putting in an actual network in a duct system that goes through these communities that could be tied in open access and available to anyone that could make a business case to go serve those communities. That's game changing, right? So you're right there solving something like rural broadband expansion. Then we thought about 5G was a buzzword for a while, but the same thing. You're trying to get to a bunch of towers all over the place. Well, that's another symptom of the legacy networks. You're building these regional networks to towers and having to anchor them back to certain what they call MITSOs, and forgive me, I don't even know what that stands for, but it's the wireless switching sites that you would use for a wireless network, right? And instead of having on and off ramps all over the place to build shorter sort of access points from the towers to the networks. I mean, edge computing was a buzzword for a while, but again, it's putting the compute further out in the edge, connecting the long haul to the metro in an interesting way that allows you to sort of shift smaller loads closer to the users on the edge. This would fit that completely. But to go one step further, and really why we got into this is we looked at the scale in healthcare. We realized that there is a future network that's going to need to exist at some point that I would call a truly distributed content and storage network. And this is the idea of, on this network you build, all the AMP sites that you have every, say, 60, 80 kilometers, each one of those sites, instead of it just being an AMP site that regens the signal to go to the next AMP site to connect, say, Chicago to Seattle, it could also be on and off ramps. Right, you could start dropping nodes there to be on and off ramps to the network. But you could also drop small compute and small storage nodes in these as well. Now, if you are able to start spreading out the compute and storage into what would historically be called long haul AMP sites every 60 kilometers along a route, with the opportunity to do on and off ramps of that network, now you're talking about a truly next generation long haul network that starts to service the needs of everything we talk about every day.
Mm. I, how so in the past, outside of, let's say, telecom or bandwidth specifically, it seemed like the marketplace would solve this problem. Meaning, we build an interstate system, And one of the early resistors to that was not so much the standardization and the right of way, although certainly that had to be solved, but it was who's going to serve anybody? Where are these gas stations going to come from? What are the capillaries? The state or county connect. Well, the states, the counties figured it out. Entrepreneurs got on board. They bid for the right to build that infrastructure following DOT guidelines. They bid for the right to have the exit ramps, and even near where I live, we're building in more exit ramps. Where 30 years ago, we're on the every mile system. We didn't have one every mile, and now we've got this. And the marketplace is coming to the original infrastructure deployers and said, "Hey, look, we've got an idea. Here's how we could bring in revenue. Here's how we could service your constituency, et cetera, et cetera." Is that the same mindset? And I'm completely ignorant, so forgive the ignorance of the question. But it seems like on the one hand, like it is, if to your point earlier, if I'm the infrastructure owner, I built this long haul. I may or may not want to be more cooperative or entrepreneurial or whatever to either upgrade it or get access to it or whatever. But in other places, the marketplace would just solve it. So maybe I'm not asking it the right way, but I'm wondering, one, are providers open-minded to the marketplace to allow them to innovate and solve the problem? Or two, is it just going to take organizations like your organization that says, man, we see a problem, but we're going to have to get into it big. We're not going to be, we can't do it in the micro level.
Yeah, I mean, to be honest, for better or worse, I see it being solved through this sort of piecemeal approach we're already doing now, right?
Okay.
Which is a certain tipping point reaches between certain markets, and then it looks like a good financial case to do it. The institutional private equity funds back a company capable of constructing, hopefully, and then they go do that build. And we've seen that happening, here and there throughout the country. But literally, I can count those types of scenarios on one hand throughout the entire country. There's not an ambitious, nationwide project for this, right? And I don't foresee there really being one, probably mostly because of the regulatory challenges, right? We've seen even some content folks themselves try to create entities to go out and construct on their own. But the FCC has its language. A state administrative code has its language. A county and city charter will have its language about what broadband is and how it's regulated, right? Or what fiber optics is, or what telecommunications is and how it's regulated. And all of these things get confused in the minds of those three entities, and they end up in conflict with each other. And no one's actually right. It's just poorly written regulation that doesn't actually apply to what we're trying to do, right? It's kind of a typical symptom of that. So I think we're going to end up solving it the same way we've been, which is chasing our tail to some extent. I don't think there's, and probably the reason that we're going to end up in that scenario and continue to be in that scenario is that there's no really good business case other than the things I've described of multi-layering business cases into a long haul network that looks clear to a financier to build these networks. And I think the reason really being is that the underlying, like if you build a building, you have a lease or you own the land, right? And it's really clear. It makes sense the asset, you're putting it on that property. You understand what the laws and regulations are of that location. You can assess the risk profile pretty clearly. When you're quote unquote piggybacking on another private or public right of way that's not for the purpose of what you're doing, that becomes a little bit squishy in a financial model as to, okay, what the cost of that is and what the risk analysis becomes of how that can affect your model over time, right? And so I think that one variable, anytime these ideas get to the right level of a fund with the right amount of money to discuss these ideas, that gets zeroed in on pretty quickly in my experience. Is, well, we're dumping a bunch of money into something we essentially don't really own. Well, no, you do own the duct, and you think about the duct as the building and the fiber is your tenants, right? Like, but no, that underlying land, yeah, you're subject to OSHA regulations of the gas company and all the stuff that the gas company is going to require you to do, which may make it difficult for you to meet, say, a 4-hour mean time to repair or whatever it is you're thinking about in your telecom world. So that is really, I think, kind of the main reason why it's not going to happen sort of in one big ambitious project. But let's use some examples of like cable landing stations coming to certain areas, right? And they create a critical mass that then, well, now you just have to have fiber built from this rural area on the coast into some interconnection point that ties into national long haul networks. That's an example of a critical mass being reached and and getting over the hump with sort of institutional private equity money to go dedicate time and resources to building something like that, right? So that there is going to be regional projects like that I would call long haul as they go over a couple hundred miles that are going to happen and still and are starting to happen as those critical mass points reach. What those are today is the concentration of compute and storage for AI, explosion of AI, and of subsea cables connecting continents, right? And if you look at kind of those two things, where we're finding a bit of a niche is connecting those locations, building network that we own that's diverse. But again, we own and operate and maintain. So we don't end up in 20 years looking at the networks I'm building today going, oh, why is it half of it bad and we didn't know? We're paying attention to the assets we build, the next gen networks we want to build. We want to actually keep good records of all these fibers so that we know, what the life of the cable looks like when we look back. None of the long haul networks legacy, sort of have that data. So yeah, I mean, really to answer directly to your question is that the long haul is probably not an ambitious project that just gets built overnight due to the regulation and the disparity between federal, state, county, city regulation and how that works. But you will see as critical mass reaches, cable landing stations and data centers builds will be done. Now, can we, in that process, building from a rural cable landing station to an interconnection point, think about the things that we're talking about here today, like rural broadband expansion and 5G and edge computing and things that might matter along the way. And we can start using some of these as regional reference designs to prove the case, proofs of concept that these networks can be multi-use and serve more of a purpose than just connecting a content company landing station to an interconnection point in a big city.
I got to be honest, I'm a little disappointed in you right now. This is such a provocative conversation that I would have expected an intellect like you would have suggested more time, because I'm so provoked by what you've said right now. I want to go in 10 different directions. Or you're a genius because now I want to have you on for 2 more conversations in the next 6 months. I guess this is my reaction. So makes complete sense, but this is my reaction. When I get on an airplane in Atlanta, that airplane, my wife has I don't have a pilot's license, but I'm fascinated by watching these videos of people get on their private plane and they fire it up and they call into the control tower and they program their systems. And then she's like, why don't you stop watching it and go do it, go learn how to do it, or stop watching it and go do something that you are going to do. I'd like, be quiet. And I roll over and keep watching my stuff. But what's fascinating to me, Allen, is the synchronicity of the handoff as they move from startup to the local tower, to the regional control of that metro area, to every single component, how the marketplace has responded. So you've got federal control, county control, state control. You've got the marketplace that has made apps for tablets, that's made infrastructure that goes into the airplane that has to be compliant, it just over and over and over. And that single pane of glass can fool you into hiding the complexity flying an airplane underneath it. On the one hand, it's super simple. On the other hand, it can be incredibly difficult if the conditions change or whatever. So you just see this synergy. I know enough and have been around engineering enough to know this simple elegance on the surface is incredibly intricate underneath. But we don't want planes falling out of the sky. We want to know who comes into our airspace. We want to control the federal controlled areas from the private. We want to open up the skies to our citizens. And so we have different layers. We've got different widths. We've got all of these things. And it's super important. It's a strategic initiative to us in 100 different ways. When we talk about telecom, while initially I understand probably the easiest way to go get the right of way was rail and gas and whatever. What railways start really 200 years ago, 1840s maybe, like in a significant way. When a
Many of
federal
those right-of-ways predate states and corporations.
For
Yeah.
sure, right? And they just impose their will, right or wrong. It's not that kind of commentary. And then later, the telegraph, and later the oil and gas, and et cetera. Today, I talk to a lot of people that are in the user right of way for intermittent energy sources, whether it's wind or solar or whatever. Is there not a compelling reason for, and I'm a libertarian, like I've said this a million times on my show, this is not representative of QTS's, this is me, sort of smaller government kind of person, federal government anyway, and yet it seems to me like this is a clear thing, and I don't want to wander too far down, but just like, wouldn't this just be a federal initiative that said, look, this is a strategic imperative for the not my grandkids, like 10 generations out, that we have, we solve this problem. We don't keep trying to retread the same old paths, because they're in conflict now. What might have worked for 100 years, 30 years, whatever the time is, we now need new paths that are purpose-built to solve these problems, because when we're talking, at the end of the day, the connectivity is just to move data. It would seem like this would be important to us to figure out how to do this. We have airport expansion projects, we have port expansion projects, and when we don't do those and they don't go well, we saw the stresses on systems in the pandemic with boats off the coast for a variety of reasons and all these other things. Is there not a you don't think that there could become like our legislature could say, the federal legislature couldn't come and say, look, we'll take all comers and initiatives, we'll figure out a plan, and then we're going to go apply that? You just think there'd be too much resistance to that?
It's a really good question. I love where you're going with this. You have to look at it like this. Yes, I think there is political will. We've seen political will in funding broadband packages, right? Hundreds of billions of dollars. So there's political will for money, but there's not political will to do what you're talking about, which is understand the whole problem and come up with holistic solutions. I think that's where the problem lies, right? And so we got to look at, okay, we're starting from scratch, essentially. Here's this, what is going to be the next build out? How is it going to be done? So if we're starting from scratch, we can look at, well, where are we today? What are the conditions we're in? And how could this stuff happen? So, energy is kind of number one, right? Mm-hmm. Demand from data centers, demand from where we want to go with EVs. We're going to have to triple, quadruple, the energy supply just in the United States to meet that.
Right.
And we don't have high voltage direct current transport lines from the Southwest to pipe solar out to the coast where all the people live. Right. And we don't have high voltage direct current transmission lines from, the eastern front of the Rockies to the East Coast where all the people are. But what we do have is natural gas, courtesy of the shale oil revolution, that we're basically pricing like a waste product in this country compared to the rest of the world. You look at the Henry Hub as it compares to the AAG or other European gas indexes or Asian gas indexes. It's nuts. We're complaining about a 50-year average right now, right? So if we look at it involving all of those things, it gets so complex so fast, right?
Yeah.
We're going to do this broadband initiative that's going to involve nationwide right-of-ways in some type of federal eminent domain that's going to be linked with an energy policy that's going to, build, who's going to build the HVDC lines we need from the right locations to make sure we're being green about this, or as green as we possibly can be about this massive growth. But the reality is that industrial growth is already happening here and is very likely, given our trade policy, to increase massively. We're trying to shorten the supply chains. We're trying to bring it home. If you lop out, NAFTA from America's economic activity around the world, it's exceedingly low percentage of our GDP that's really involved with the rest of the world. It's mostly foodstuffs and energy going between US, Canada, and Mexico.
Hmm.
right? But and now with Mexico really picking up the slack in manufacturing and automotive and aerospace in northern Mexico, like this is the partnerships we got to lean into, right? That
Right.
to solve these problems, right? But when you look on sort of the larger scale and all the other locations that are going to try to meet these demands, like our challenges are a lot lower than the rest of the world for all of these reasons. And a big part of it is what we've been talking about. It's the geography of North America. So the same problem that makes it really hard to do rural broadband expansion is the distances between. But it's also what allowed us to have the suburbs and not have to industrialize overnight like other nations did. So we're not in like a rapid demographic collapse. We still have, labor force coming and a big generation of the millennials that are likely to have a bunch of kids and create another big generation, which the
Yeah.
rest of the Western world and civilized world doesn't really have that, right?
Right.
So we're looking at, I think that's that demographic issue in conjunction with the North American industrial growth demand, those are both very inflationary things, right?
Mm.
And they're hitting at the exact same time. And we're saying at that moment in time, how could we do a grand national project of expanding broadband networks that fit the needs? And so when I think about that, that's a very complex situation. If I'm going to see a path forward, I think it has to do with combining the priorities. If somehow you can link energy, telecommunications, and a transition to a greener economy, we'll call it. I mean, because there's no light switch we're ever going to flip that just turns off fossil carbon. But
Right.
how do we transition? I mean, combined cycle natural gas and using that resource that we are literally flaring off every single day, 24/7 in certain basins, could be much better used with what? The construction of new pipelines. Well, what could go along with the construction of new pipelines from these pretty much remote locations that go to the population centers and the ports and the transport networks? Fiber optics. So all this stuff could link theoretically. It makes sense, but it would take sort of a first of all a reference design that makes sense that involves a chip maker, a cloud maker, a data center operator, and a fiber constructor and a gas pipeline. And if we could make a reference design between all of those and say, hey, this is where we think we want to go, well, then maybe you have something tangible you could bring to a political entity to say, let's create the will among the people. But how do you distill that down and explain it? Because it's such a complex thing. I mean, really, it's simple in the fact that you just have to meet a demand that is far outpacing the supply. But it's complex in that demand is not just a single demand in a single location for a single thing. It's spread all over the place and it's sporadic and it needs to be dynamic. But the infrastructure it lives on is stuff that takes a long time to build. And so those two things are in conflict in how they're financed and how they're put together as projects, and then how they're seen as political will to move forward in any type of legislation that's going to solve the problem. It seems like we're only really willing to just throw money at things, right? Because we don't really know what else to do. It's too complex, and we think, well, that'll solve it. There's billions of dollars for broadband. Why don't we have broadband everywhere, right?
Right.
It's all of these dynamics working together. And so I don't know what unifies it or if anything is able to unify it, but much like yourself, I see the potential is just huge, right? And if there's some maybe ETFs that could be created that involve all of these things, but then people could understand, well, I'm investing in something that is actually, hitting each one of these sectors and solving the larger unified problem that's remains unsolved.
I have like 3 pages of questions here. I think we've gotten to 2. But I just want to react to what you just said. So in my world, there's a lot of talk about the single most important thing is access to power. And that's sort of right. It is certainly, if you've got a big building that doesn't have, that has, I would argue data centers have the ideas of the whole world. There's no healthcare solution. There's no formula from Eli Lilly. There's no sermon. There's no route for a Delta airline or whatever that doesn't live in somebody's cloud, in somebody's data center. They all live in this digital infrastructure somewhere. But what we're finding as it relates to energy is this willingness with a number of the national labs, which is the federal government, to partner with a wide range of energy sources. And by the way, they would say, kind of what you're saying, energy generation, as tough as it is, isn't even the toughest. It's the transmission and distribution and the right-of-ways they're not sexy. It's far and away the long pole in the tent Which, by the way, I had to look that up the other day. I was like, I've said that for 25 years. What the heck is that? Who even has tense anymore? But anyway, but there's this willingness. And so you see organizations like ours that are not only talking to public and private energy generation, whether it's a utility or private, gas turbine people, microgrids, because you can have all this generation, but if I don't have the ability to distribute it, and so now we're talking, our industry is talking to all of these groups. Like, how do we generate the power? How do we condition the power? How do we transmit and distribute the power where I'm not going across county lines, like it's in the campus? Even better than that, I can now, if I need, let's say, a unit of 10 for the next 20 years of capacity for me and two of my frenemies who come and help me do this, but this community is going to grow up around me and they might need 10. So we could build the capacity for ourselves for the next 20 years easy with modularity that can be expanded. But when we build that out, you want to talk about being a good community partner? If I can build in to where I'm connecting to the 50,000 or 100,000 homes around me, not just the data center infrastructure and the fire department and the sheriff's department and all these other things, and possibly connect back to the grid. I know some of this is ambitious and I'm skipping way past some of the engineering complexity. But now I'm not trying to go over aging transmission lines. I'm not trying to do any of that other stuff. I'm literally building this infrastructure and then distributing it out instead of building an energy source somewhere else and distributing it to it. And we see so much momentum and potential for something like that. I wonder if there can't be, something either in the marketplace or some of these other agencies that say, hey, look, let's, storage, whether it's energy storage or literally data storage coming alongside with that. It just seems like there's so much potential. And I wonder if some of that will bleed over into the connectivity race, whether it's back to low Earth, LEO, low Earth orbit, satellite infrastructure that you were talking about that I'm reluctant and want to see more of the studies about these constellations. I don't want to fill my sky up where I can't see the sky above us, but it just feels like there's an opportunity and a willingness, if we can find a way with power to have these conversations, because it's critical. And that's inexpensive, reliable power that I'm not interfering with base load that's already on the grid. I'm actually solving my local problem and then distributing back. I don't know. I'm pretty optimistic about the potential of this, but what is your reaction to that as it relates to your
Yeah.
world?
I think, again, you're hitting on a theme we've had today, which again comes down to geography. And when you talk about the SMRs and the small modular reactors, this is a solution to that geographic problem in every way, whether it's for data centers or, I don't know, you have a hurricane that takes out a power network, you can just drop an SMR in to take care of it. I mean, so setting national security concerns aside and proliferating, that type of material is not my department. I know nothing about that.
Super safe. It's not
Theoretically,
weaponized.
from an energy source
Yeah.
perspective, an SMR is the perfect solution for all this, right? And I
Yeah.
think we've probably known that for 100 years or more. So the but the political will to do it, like you said, long ways away. The engineering certainly could be accelerated. It's not new science. It's well-established science, and we're the best at it in the world. And I'm certain, if we really wanted to do a Moonshot project, we could make that stuff work,
Right.
commercially viable. But if you don't have that, which we don't, let's say for at least, like you said, the next 30, 40 years minimum, right? Then you have to look at the sources you have today, and you have to build around that. And so what we've got, again, it comes down to natural gas. And where is that natural gas? So a good example is, like, if you look at, pictures of the Earth from North America from space, and you see, west of Bismarck there, out in the oil fields at night, it's just this huge, it's just lit up, right? And it's not a disco party, it's flare off from the gas fields, because
It's
we
Mordor.
cannot capture. Yeah, we can't store it, we can't transport it, so we flare it off.
Right.
Dropping, if it was all about generation, like you said, we could just drop combined cycle natural gas right there in North Dakota and generate all the power you would need with the free flare off.
Right.
But it's not about that. It's about moving it around. So if that's an energy source that's viable today that we could use, then how do we work to that to our advantage? Well, we get to work on, subsidizing the pipeline networks that would make sense to capture that stuff, store that stuff, and move it to the places that it needs to be moved, relative to the demand we're creating in EVs and data centers, let's say, for two massive examples. But the same thing again, you could do regionally things with like Southwest. We have great solar potential in the Southwest. I mean, we're not going to be doing a data center solar project in Boston. That wouldn't make any sense. But in Phoenix, it makes a heck of a lot of sense, right? Geography matters. And so if we look at, okay, how do we build around the energy sources that are available today, right? That's so partnership in as we do a design for, well, how are we going to build, facilities to move this gas around, which I think is inevitably going to happen, right?
Yeah.
Political will or not. I mean, if oil prices go up high enough, right, we sort of shut down exports and keep it cheap for ourselves, and then we get to work on building this internal gas network that we're going to need to distribute all this stuff, right? And I think that if you do that in conjunction with the ideas of what are the biggest demands, EV charging stations and data centers, and we need to connect those with fiber optics, well, then all of that stuff runs together. You've got a right of way, you've got a new construction project, more. So in the environment of high cost of capital, high cost to labor, right? And if you're going to do some type of moonshot like this, that's what it would take, is that partnership. And I think back to that point is you've got to center it around energy, look at where the viable energy sources are today, and then develop reference designs around the demand for that energy and data consumption, which are one and the same, right? It's not like the EV doesn't consume data either,
Right.
right? Sure, the data center is the big data consumer, but as much power as EVs are going to consume in many locations all over the place, data centers are going to consume in more monolithic locations. You're still going to need lots of connectivity to both of those things. And that's where I think, unifying that design, if you're able to overcome some of that hump, what we're going to do in the network world is going to react to what the real money is doing. And the real money is building subsea cables and data centers.
Yeah.
And so as that real money does those big projects, our little fiber builds are still just kind of rounding errors in that, right? But if you were to look at us as maybe more of a rounding error and include us in the reference design for, again, the long haul network, the diversity and replacement of the long haul, to hit the locations that are important, create these next gen networks with on and off ramps that can supply all of the needs for all of the demands up and down the stack, from individual users to the largest consumers like the content companies. I think that's really the ticket. Is it possible? I don't know. It remains to be seen. But we're certainly going to try. I think the demand will continue to outpace the supply, and that growth factor probably increases in the near term. And there's going to be so much money and effort thrown at fulfilling that. I don't think we'll succeed in supplying all of the supply for the demand, but we're certainly going to try. And that's where we come in, is looking at where are the important locations going to be. Can we get? We're always looking for a tip on where to build.
Right.
Well, it's good to go build there, but we find that out, like almost too late. And then to get there on time, to be the first mover advantage, becomes a bit more of a risk, at least as the infrastructure money sees it. If it's included in the original designs, it's not so much a risk. It's not a rounding error, but a piece of the business model that is, should be there from the planning stages, so that it's there when you go to deliver to the customer.
Yeah. We have found that, it's so interesting. Our heritage, my company's heritage, QTS, we came from ALEC. So they built out this data center in 1999, and we were a co-location provider. So we throw around the term data center. If you're in the data center industry, you can be a data center without being co-location, that co-location product. But you can't be a co-location product without being a data center. And so we come from a history of a heavy telecom, sort of the service side of it, and then the IT workload, servicing those, but we really understood the necessity not just to be latency sensitive, but we really don't come from the landlord real estate world. That we look like it now because we have this, a big development group, and we build infrastructure and these other things. But really our whole DNA, everything we're about, is from that world. And so one of the advantages for us is we've got these really smart connectivity telecom people with these IT people, with these data center engineering people. And we learn, I'm sure you know this, from the early days of IT, it's always three legs of the stool. You got to solve the compute problem, You got to solve the storage problem. You got to solve the network problem. If you don't solve them equally, whatever the weak link is, that's the performance. If my storage can't keep up with compute and bandwidth, I fail. If bandwidth can't, how many times in early days, especially, I'm an old University of Texas IT person, and we were so excited because we rolled out our new, I don't even know what they were, 286, 2U server so fast. They left skid marks on our desktop, and we were so excited about them. And we all of a sudden we get a call from Central IT. You just brought down half of, the campus because we scheduled we just left it default. We didn't even schedule it. Every backup ran at 5 o'clock on a Sunday afternoon and crashed the network because we didn't know how to balance the loads, or on and on and on. And so over a decade and a half, we figured out how to get those things, to have those conversations, those collaborative conversations. There could be one part of the day where virtual machines, sort of that group, might be getting all the love as opposed to storage or network, or it might be the network people or whoever the technology of the day. But we learn the hard way that we have to be collaborative and integrated, because if our brother or sister in one of the other points of this triangle fail, the whole system fails. It just doesn't work. And in data center world, if we do not have that connectivity and power, we got to have stable, environment power. So data center's got to be always on, whether that's heated, cooled, operational, reliable. Electricity can't hold its breath. Computers can't hold their breath. I have to be connected at whatever it is that I'm distributing out of that thing. And I have to be secure. I have to have, those are my three legs of the stool: on, available, and secure. And so it just feels like as we go forward to solve these problems, we bring the energy people with us, whether they're natural gas, whatever it is, whatever the energy generation. And I think it's going to be iterative. I think it's not just going to be, how do you snap in SMRs, which are really attractive. The technology's really pretty incredible. This is not weapons grade material. There's just so much good work that's being done there. But that's a ways away. We got hydrogen, we got natural gas, we've got so many other things that could serve up base load right now, today, that's stable with carbon capture and these other technologies. And I'm a little over my skis. I'm spending time talking to people. I'm not an expert in that area, but I see the willingness of my industry for sure to engage in those conversations, and our constituents who use our services for their AI workloads or for their healthcare networks or whatever it is, because they're trying to solve a problem. A data center is just the fort that everything lives in. We don't make the data. We just provide the infrastructure for it to operate in, and so we need that safe, secure world, and it's got to be affordable. So it just feels like maybe we continue our conversation next time, because there's so much about the details I want to get into. But like whenever I get smart people on here, we have such a fun, provocative time. I feel like we're teeing up some of the conversations more to be had in the future. What haven't we talked on that we should, before we wrap it up today, we should finish the point on?
Yeah, no, maybe one other power source we didn't really discuss that's there is hydro, right? And I think at least in Pacific Northwest, large content companies have tried to take advantage of that super cheap power in certain locations. And the regional power transport provider that actually did have OPGW high transmission fiber on their high transmission lines, that seemed like a pretty good pairing. But due to the ownership structure of that fiber and how it was or was not able to be used, none of that fiber ended up being used. The power is used, but the fiber is not. And it took, I don't know, an extra 15, 20 years to get the fiber builds done after the content company had chosen the location because of cheap power. So yeah, looking at maybe from a regional perspective, like if we look at the hydro in the Pacific Northwest and these networks, could fiber be a solution there? But in the past, what we've seen is it's just not their core business. So it's been difficult, right? But if the big power consumer, their core business is power, is also saying, hey, power distributor, I also want fiber optics. And if the power companies, the rail companies, the gas companies, I think they're starting to learn this because we've had conversations with them recently, start learning about technologies like fiber sensing, where you can use fiber optic cable like an ultra sensitive microphone.
Yeah.
Okay, so you can make it like hear with an infinite dynamic range. You can hear the quietest thing and the loudest thing and not overload. And you can feed that into what we call symbol layers, and you can make symbols out of sounds, and then tie those symbols to actual real world events. That's huge for safety on a rail or a gas network or transportation network. And so there's finding those synergies and reasons to do things mutually, I think will maybe help. But until we're able to look at that as a group from the right of way, the energy, and the communications all together, right? We're probably going to still suffer from the same symptoms that we've been suffering from in building things piecemeal. But yeah, great conversation, and certainly looking forward to any future conversations you'd like to have, David.
Well, a bunch of them. And I remember in 2000, no, gosh, it had to be before that. It was the late 80s, early 90s. I worked at a company in Louisville, Kentucky, and they would string a very rudimentary, basically piece of fiber through the fence. There was security, access control and security. And they had no way to tune the way that you're describing. I can't even imagine 25 years later what the technology would look like, 30 years later what the technology would look like. But that was it exactly. And they would connect it to these optics. And it was such an effective, and all they were looking for is like somebody cutting the chain link fence. And it's so distinct. And there was no real AI model, but they could tune these sensors in such a way that if you hit within this frequency of that thing being snipped, it would alarm. And what that did was, animals climbing the fence, running to the fence were ignored because they weren't the distinct frequency of cutting. And you imagine now 30 years later of technology, of attenuation, of the sensitivity and the ability to do that. I'm gonna have to go get some fiber and lay it around my yard because my neighbor's dog But anyway, another problem, another day.
For all utilities, though, it's amazing because you could hear the backhoe coming before he gets to your utility, right? It's called preventative maintenance for the first time in history on a utility, where instead of having somebody just stake out and watch the right of way, at least you can listen to it and you can hear the backhoe coming, right? He didn't call 811 for dig. He's digging close. Dispatch, get out there and stop him before he cuts the
launch
fiber,
a little regional micro drone that fires a paintball off, shoots him in the forehead. And even if they do end up cutting, they've identified him as the idiot who did it because you can't wash it off. That would be so much fun.
He's got a blue forehead. Yeah, that's right.
Alan, thank you so much for coming on today. I loved it, and I cannot wait. Thank you also to Leslie, who helped coordinate this thing on your staff. Pretty awesome. I appreciate it. For those of you who listened, if you liked the conversation, subscribe. And if you loved it, like it. We'll see you next time, everybody. Have a good one.